Okay, hello everyone. I'm JELENA MARAVIC and I work as a JavaScript developer at Levi 9 company. I'm thrilled to be here with you today to discuss a topic that is near and dear to every developer's heart, and that's maximizing the performance of React apps. Not so long ago, my team and I faced a great number of challenges while implementing numerous features in a short period of time, which led to an overall reduction in app performance. We'll discuss these challenges later on and see how small changes in our coding approach can have a massive impact on user experience and overall efficiency of the app. But before we dive into that, let's familiarize ourselves with the essential toolset at our disposal, the DevTools. Okay. React DevTools is an extension created by React team. It enables developers to debug their code inside developers' tools. By installing this extension, you will get two tabs called Profiler and Components. By using Profiler, you can investigate how often and why your component re-rendered, and it is used to record performance informations. By using components, you can inspect and manipulate the component props and state in real time without reloading a page. In this image, you can see how components tabs looks like. On the right-hand side, you can use stopwatch button when you want to see the loading state of your component. To make this work, you should have been previously wrapped this component in suspense. The next one is the eye icon, and it is used to find the DOM element in the Elements tab. The debug button logs all the data about the component to the console. The next one is the source button, and it's used to see the source file for your component. On the left side, when you select a component, you can see its props, hooks, and also the component hierarchy. Now we'll cover some important parts of the profiler. The first button we use to record performance information. The next one is the refresh button, and it's used to refresh a page for a session. The clear button, it is used to clear the profiling session results. The flame chart button, it is used to show the component list like you see in the image. The ranked chart, it is used also to show the component list, but in ranked manner. So you will see on the top the components which took more time to re-render. Next, you can see the commit chart. It shows all the shows the list of all commits during a session. The commit chart is used to show all the components that rendered during a session. So when you select some component on the left side, you can see the information why this component re-rendered and the time when it re-rendered. So here we can see how DevTools work together. On the profiler, we can find information that hook 1 changed. When we switch to the Components tab, we can find which hook changed, and it is the state hook. And after this, we know what we can focus on when improving the component behavior. Two awesome things in Profiler you get when you enable highlight updates when component re-renders, so you can visually see which component re-rendered while interacting with the app. The next one is record why each component re-rendered while profiling, so you see the render information on the right side. So now we'll shift our focus to the most common coding mistakes you have probably encountered while building React apps. We will examine each of them and understand why they're problematic and explore ways to resolve them. The first one is creating component inside another functional component. In this example, you can see that array sum component is inside component. When we make a change to the component and the component gets recalculated, it needs more time to re-render. A better approach here is to take an array sum component out of the current component, and this has two perks. The first one you can see in the recorded profiler session. It speeds up the rendering time by avoiding the slower remounting process of the component, plus it cuts down the chances of running into strange bugs. The number two is setting incorrect value for the initial state. In this particular example, I was testing one part of the app that was not connected to the SQL editor, and the change there caused the SQL editor component to re-render. Then I checked why that happened, and it was because of hook 47. I switched to the components tab and found that hook. And after I figured out that issue here arises from generating new empty list references with every Redux state change. The solution here is to always set up your initial state in the right manner to allow your selector to efficiently return the specific portion of data it requires. Then you wouldn't need to have the conditional value return, as state is handled right, and the Redux knows how to handle this, not to re-render the component. Number three, not moving state down the component tree. In this example, you can see that component has model state in it, so any change to the state would cause both component and model to re-render. The better approach here is to move open state to the model, as logically it is connected to it, and not to the component. In this way, the state change won't trigger a re-render of both components, but only the model. That is what you can see also in the recorded profiler session. The next one is the fourth, and not memorizing the child prop value and the child component itself. When we structure components like this, the state change on the parent component will cause child component to re-render. To avoid this situation, it is necessary to encapsulate the value prop within React use memo. Additionally, the child component should be enveloped within React memo. By implementing this approach, we retain the reference to the value object, thereby preventing its recreation with every parent re-render. Furthermore, by memoizing child component, it remains unaffected by parent re-renders and won't trigger unnecessary re-renders. And you can see that in the second approach, the child component did not render. Number 5, wrapping parent component in React memo instead of a child. It is a common mistake to assume that wrapping component with React memo will automatically memorize its child components. In reality, memoization works on a per component basis, and each child must be individually wrapped in React memo to achieve memoization for them. Memoization doesn't cascade through the component hierarchy by default. This distinction ensures that memoization is applied effectively where needed and without unnecessary complexity. Number 6, not memoizing provider value. In this example, not using React memo for the provider's value will cause the parent changes to trigger provider and its consuming child components to re-render. This happens due to non-memoized value, causing a ripple effect in the component tree. To optimize, use React use memo on the provider value to reduce unnecessary re-renders and update the tree only when needed. Also, since we don't want the child component to re-render, we wrapped it in React memo. Key takeaways. Using React by itself will not result in a highly performant application. You should conduct audits periodically. tools provide you with really powerful performance measurements for your React app. So it is crucial to know to read and understand them. By understanding React better, you can quickly identify unnecessary re-renders and easily fix them. Enable highlight updates option in the profiler to visually see changes that are happening while you interact with the app. And if you have any issues when finding a solution for a particular issue, do not hesitate to Google it. There is always someone who encountered this problem before. Thank you.